Uh, Good morning, everyone. And I want to welcome you to week of revision. Of course, the plan that I have this week, Monday and Wednesday, is to go over practice questions and to give you information about, um, what is needed in the exam. On Friday, I'm going to start a new topic. But this week, Mondays and Wednesday, we actually be committed to this. Of course, your midterm is on Monday, right? Okay. So this has already been published. Okay. Um, this is practice questions, like I said. Um, you before now, you've done a lot of stuff. Of course, the areas that will be tested. I want to believe these practice questions will give you an idea. But before I go into my review, um, I need you to review what you've done in multiple linear regression. How do you test hypothesis about individual um, predictor? Of course, before now, I walk you through inference. There's a particular area that I will talk about the goodness of fit and inference, where you test hypothesis about regression coefficient associated with a predictor, where we make use of a t-test. And of course, I remember making use of f-test. You test, hypothesis involving a model with covariate and model without covariate. I think I remember I walk you through that where we make use of the f-test. Okay, so that area is actually going to be tested. And of course, you need be prepared to answer theoretical question on the role, the ridge regression, lasso regression, and all subset selection and stepwise regression play in handling multicollinearity. I'm going to say that again. Make sure you review that area because you are going to answer theoretical question. I mean theoretical question, okay? Theoretical question that could come in form of a multiple choice, okay? Where you actually, you need to understand the role played by lasso, ridge regression, or subset selection, and stepwise regression in handling of multicollinearity. Okay, and not only that, and that's why I put in the practice question. If you take a look at this, okay, if I'm talking about the ridge and the lasso regression, can you explain lasso regression? Can you distinguish between ridge and lasso regression in terms of regularization penalties, in terms of variable selection, in terms of shrinkage effects? Okay, of course, one use L1, the other one use L2 penalty. And the one that does that do the job of a variable selection is the lasso. Okay, lasso do the job of variable selection. The ridge regression does not do the job of variable selection. Okay, it's still going to, we're still going to have all the predictors in the model, except that it will be able to reduce the effects of multicollinearity. So look at the shrinkage effect. When I talk about shrinkage effect, one shrink towards zero, the other one shrink, force the coefficient to zero. Okay, that's why they are not in the model. Then I will also advise you revisit the residual sum of squared. The residual sum of square for OLS is different from residual sum of square with ridge regression is different from residual sum of square with lasso. But the residual sum of square for OLS for the least square, of course, um, it is a sum of squared error. When I say residual sum of squared, okay, this is what I mean. Okay, now it is the residual sum of square here if I add lambda summation beta j, okay, beta j squared and j star from 1 to the number of that. Okay, this is the residual sum of squared for the ridge regression. So you have to get yourself familiar with the residual sum of squared for the ridge regression. Then for the lasso, the residual sum of squared, you're actually going to have, or let me just say the loss function. This is the loss function for the ridge, and the loss function for the lasso, okay, is going to be in the absolute term. Okay, it's going to be in the absolute term, as you can see. Okay, so when you take a look at the two loss functions, they are not the same. Okay, one for the ridge, one for the lasso. So you need to get yourself familiar with all of that. If there's going to be question, probably the question could centered on the shrinkage. It could centered on which one does the variable selection. The question should centered on, okay, if I'm actually seeking an explanatory goal, which one of them should I use? If I'm seeking a predictive goal, which one of them should I use? Okay, because lasso has advantage over ridge. Ridge also has advantage over lasso, depending on what your intention is. Okay, so there's gonna be like, and that's why take a look at this. Suppose you are given a data set where lasso regression selects only 3 predators. Why ridge regression retain all predator with small coefficient? Okay, it didn't get rid of them. Okay, even though they are not significant, they return them, but they are, the coefficient is going to be small. They're going to be in the model. Then I'll say, however, stepwise regression select 5 predators that are different from lasso, from lasso cell selection. Okay. Now, what does this tell you about relationship between predators? So what does that tell you? Look at that. The variable selected by lasso is different from the variable selected by, the stepwise regression. Okay. So what does that tell you? Okay. Now, what does actually tell you is that there is presence of multicollinearity. Because if there's no multicollinearity, that shouldn't happen. Because for lasso to have selected only 3, okay, it means the lasso has succeeded in shrinking the coefficient associated with the problematic variable to 0. They've been eliminated from the model. So lasso can only do that. Lasso is doing that to treat the problem of multicollinearity. So I said ridge regression does not eliminate variable, but shrink their coefficient, and which indicate that predators are highly correlated. Okay, when the ridge was able to shrink, then it's giving you an impression that the variables are highly correlated, and that is why it shrink their coefficient, towards zero. And I said, Lasso, on the other hand, select only few predator and discard the rest. If different predator carry similar information, okay, if different predator carries similar information, Lasso might arbitrarily choose one while discarding the other. What Lasso normally do, two variable are causing problem. So Lasso at time can discard just one of them and still retain the other one. That's what it means. Okay, that's what you can see. And I said stepwise regression selecting 5 different predator suggests instability in variable selection. Okay, instability in variable selection. I told you the other time, stepwise regression, may not necessarily do the job of handling the problem of multicollinearity. Okay, then the exam is also going to test your knowledge of metric of evaluation. Okay, knowledge of K-fold, knowledge of validation set, knowledge of, leave one out, okay, knowledge of that. And I will advise that you read your notes on comparing the test, the training mean square error with the test mean square error. Take a look at this. How will you decide which model to use for prediction? Please pay attention. We're just done with this one now. I said, how will you decide which module to use for prediction? Okay. And I said here, to determine the best model for prediction, we need to evaluate predictive performance. If you're using a different metric of evaluation to assess predictive accuracy, it's going to be an exercise in futility. So if I really want to know which model to use for prediction, then I need to evaluate predictive performance, and my target will be towards those, metric of evaluations, for predictive performance. And of course, I got like 3 of them. They have a cross validation. Okay, the K-fold. Okay, and we have a leave out and we have a validation set. If you check your note, I've been able to differentiate between the 3. So take a look at that. Okay, I said use cross validation to compare modules, perform K4 cross validation, K equal to 10 to evaluate out of sample performance. Okay, and of course, you're actually going to settle with the module with the lowest mean square error. Okay, so take a look at that. Then I said, assess bias and variance trade-off. Let's say, for instance, you want to use, you want to know the model to choose for prediction between lasso, ridge, and stepwise regression. I'm just assuming. Okay. So if I want to know, I will need to assess the bias variance trade-off. When you are seeking explanatory goal, okay, what we normally do is to reduce bias. I told you the other time, bias is the worst enemy of everyone in scientific community. But in the machine learning world, where the predictive goal is in focus, they normally try to reduce both bias and the variance. Let me tell you this. When you reduce only bias, in the statistical world, I told you the other time, if you focus on reducing bias only, then you're actually going to run into a problem of high variance. Okay? You're going to run into a problem of high variance, which means your model is actually going to overfit. Okay? But if you are minimizing both bias and the and the variance, okay, your model will actually lead to prove empirical prediction, but your model will suffer interpretation, the truth. That we call the truth. Okay, now if you take a look at this, I said if cross-validation show that, because if I want to compare between lasso ridge and the stepwise, I'm actually going to use an appropriate metric of evaluation. Let's say I choose K-fold. Okay, why am I choosing K-fold? The K-fold has advantage over, the validation set and so on like that. Now, if I choose K-fold and that's a let three variable, okay, so I said if cross-validation show that three variable lasso model has similar or better predictive accuracy than others, then it is preferable because of simplicity and interpretability. Why do I say simplicity? Because the lasso will get rid of some redundant predictor, which is going to make your model simple. Your model is not going to be complicated anymore. And if your model is not complicated, if your model is simple, then you can interpret easily. That's what it means. Now for reach, if reach perform best, it suggests that all predictors contribute. I told you the only condition to use reach, or one of the major conditions to use reach regression, is when you realize all predictors are informative to the model. They have to be in the model, whether they are significant or not. Okay? And that's why I said even individual effects that are small have to be there. Okay? Now, if stepwise regression has higher variance we mean unstable variable selection across different samples. Because the higher variance is going to tell you there's going to be high sensitivity. Okay? Sensitivity of model to different training data set. And that model is not going to generalize well. That's exactly what I mean. So if I were you, rate this area, focus on this area as well. Then consider interpretability versus prediction accuracy. I told you the other time, okay? When interpretability is crucial, because your model needs to be simple for easy interpretation, then lasso will be a good choice. If the prediction goal is the case, okay, I told you the other time, okay, what normally leads us to have a high degree of prediction accuracy is when there's a lot of predictor in the model. A lot of predictors in the model. Normally help prediction. They may not help interpretation, but they help prediction. And that's why reach may be preferred in that regard. Okay, and check for model stability and so on like that. So theoretical question is coming in that particular area. Now, because I have today and Friday, today and Wednesday for this, I'm going to go over problem. I've already gone through problem 2. I'm going to go over problem 3. Then I'll go back to problem 1. Now I need you to pay attention to problem 3. In 2016, okay, mortgages studied the relationship between the yield of aquifer borehole and the physical property of the aquifer or aquifer. So mortgagee collected a random sample of n equal to 54 boreholes in Ondo, Nigeria. For each borehole, the following variable, among others, were measured. They measure resistivity and the yield. Please pay attention to that. Resistivity of the aquifer in ohmmeters. Okay. Now, after that, take a look at this. You may assume that the data set represents a random sample of all aquifers in Ondo, Nigeria. In this problem, we consider the simple linear regression model for predicting borehole yield using resistivity. Please pay attention. Now, the graphical and the numerical output for the model are given below. Now, in this exam, you do not need to come to this class with your laptop because you're not going to do anything in out. I will generate arrow problem. So what this exam is going to test your knowledge of number one, knowledge of interpretation, knowledge of application, and your theoretical knowledge. Does that make sense? Okay. Now, the graphical and numerical output for the module are given below. But you are allowed to come into the exam with calculator because you're actually going to do something that has to do with matrices. Matrices. Okay? So when I get there, I'm going to let you know. So the scatter plot, residual versus the fitted plot, and the normal Kiki plot for the model are given as follows. Now, let me tell you this. You should be able to know how to interpret a scatter plot. How do you interpret a residual plot? And how do you interpret a normal Kiki plot? The three plots are very crucial in statistical analysis. The scatter plot is what is part of the preliminary investigation. Before you specify a linear model, you need to first generate a graphic, a graphical plot between the response variable and the predictor for, you want to see whether it's going to be a straight line or not, whether you can actually suspect outlier or high leverage and so on like that. That is a scatter plot. Residual plot is done after you have estimated your module parameters. And for there to be a straight line, residual should show no pattern. And let me also tell you this. Residual plot can be used to investigate two assumptions. One, assumptions of linearity. Two, assumptions of constant variance. I'm going to say that again. Residual plots can be used to investigate two assumptions. One, assumptions of linearity. Two, assumptions of constant variance. Residual plots cannot be used to investigate assumptions of normality. No. But what can be used to investigate assumptions of normality is the normal QQ plot. And for the normal KK plot, we're actually going to have a diagonal line for the data set to follow normal distribution. We expect majority of the point to land on the diagonal straight line. Now, take a look at that. You're given that and the question now. Then with a numerical solution, like they are output, and the question asks, please pay attention. In the description of the data set on the previous page, it has been stated that data set meets the independent assumption. Now, let me tell you this. We don't test independent assumptions. Does that make sense? Now, but when we are collecting our data, okay, we have a way to ensure that observations are independent. So the only, if I want to make use of those plots, I can only check for linearity, normality, and the covariance with the assumption that my data set they are independent. Okay, now pick one of the remaining three assumptions for linearity, normality, and constant variance, and use the plot in the output to check whether the assumptions have been satisfied. Now, this is what I wrote based on those three plots. This is what I wrote based on those three plots. So I will advise that you also go through that. Okay? So take a look at that. Okay, the residual plot is showing a straight line. Okay, take a look at that. It may not even be a perfect straight line because we don't expect it to be perfectly, we don't expect to have a perfect normal distribution. Okay, and we took a look at the residual plot, like I said. From what I'm seeing here, there should be violation of the constant variance because the way it is clustered here, it is, if you take a look at this here, it is spread. Okay, so if you take a look at the provision, okay, I said from the residual plot, the variation of the response is not consistent across. Yeah, that's a violation of a constant variance. Okay, So you should be able to know how to read the plots. So the exam also going to be based on your interpretation of that. Okay, so another thing is how do I find a confidence interval for the regression parameters? Okay, I gave you a formula here. The moment I know the estimate of regression parameter, I know the standard error. The standard error is going to come from the table of the output, which I'm going to show you here. Do you see this? This is standard error. Okay. So this is the standard error for the beta naught, this standard error for the beta 1. Okay, and these are the estimate. The t value, the p value. Okay, then you'll be able to consult that. It's on that. Now, how do I get my house square? My house square is in the output. Okay, look at that. We see multiple r square is 0.8401. It's part of the output. All what you just need to do, multiply by 100. If you multiply by 100, then you can see what I have here. Multiplying that by 100, about 84%. So the coefficient R square is different from R. R is a correlation. R square is the coefficient of determination. So R that is correlation is telling you relationship between the response and the predictor. The relationship may be positive or negative or zero. It could be strong or weak or perfect depending on the situation. But when I talk about coefficient of determination, which is the square of R, the coefficient of determination will measure how much percentage variation in the response the model was able to explain. How much percentage variation in the response the model was able to explain. There's 100% percent variation in the response. How much of the 100% was the model able to explain with what I'm showing you now? It means the model was able to explain 84%. Then the remaining 16% is believed to be explained by a variable that we don't consider in the model. Now, if I know my R square in the regression table, in the regression output, there is no correlation, but there's an R square. But mathematically speaking, I can get correlation from R square by finding the square root, which is what I'm doing here, finding the square root. But let me tell you this: a correlation is going to have a sign, negative or positive, but how am I going to know the sign of the correlation, whether it's going to be positive or negative? Then I need to go back and check for the sign of the beta 1. Okay, if I go into the output table, the sign of the beta 1, okay, if you take a look at that now, it's positive here, then I'm going to assume a positive for the sign of correlation. If it is negative, it's going to be negative value for the correlation. Okay, and that is that. And you know how to interpret whether strong or weak. Let me see because okay, I'm not going there for now. Okay, I quickly want to come to this. You were given this. Okay, let me come here. I think I'm going to stop in problem 5 today. Like I said, we have this review for today and Wednesday. And of course, there's not going to be a new assignment this week because we want you to concentrate on the exam. Now, this is why I said you need your calculator on the day of exam. Because if you make an attempt to solve this manually, you actually, it's going to take forever. Okay? There's a lot to compute, and I need you to pay attention. Okay? Pay attention. You know, here, do you know, um, if I if I have data set, why? Do you know initially this is the way the data set came? Okay, please pay attention. Let me write that here. Pay attention. You don't understand, ask question. You're gonna be by yourself in the day of this exam. You don't understand now. I will advise that you should ask questions. Okay, initially, this is the way the data set is 4, 1, 2, 3, 3, 4. Then y actually is in this form 16, 5, 10, 15, 13, 22. This is the way the data set is initially. Do you know that I can give you something like that and I say, okay, you know what? Give me um what is y in matrix form, what is x in matrix form, what is e in matrix form. E is the error. What is y in matrix form? What I'm trying to tell you right now, the y in matrix form is this guy. The x in matrix form is this guy. And of course, you know where the y, the 1111 come from because we are feeding simple linear regression with intercept. Does that make sense? Is there anyone who doesn't understand how we actually wrote this in matrix form? Is there anyone? If I also talk about error in matrix form, what I'm going to advise you should write is E1, E2, until how many? 1, 2, 3, 4, 5, 6, because the dimension of Y and the dimension of the error has to be the same. Does that make sense? Now, if you really want to understand what to do here, okay, the moment you get your Y and X in matrix form, you actually going to be fine. There are going to be a lot of questions. Look at that. You see why I said you're going to need a calculator? On that very day of exam, okay, I don't need you to show your work on this. You know what I want? Give me your answer. That's what I want. What is your answer? Okay, this guy, what is your answer? And if you also want to do it manually, there's no problem. But you know what I want? Answer. I want answer. Does that make sense? Now, who doesn't understand how to do S transpose multiplied by X? Okay, you can use your calculator for transpose. The moment you have your X, you'll be able to get the transpose, you'll be able to get the products. Now, I can ask you a lot of stuff. Okay, take a look at that. Ask you, if I here, because I wanted to find, maybe if I wanted to find the inverse of that, and I'm giving you a clue for those who want to solve that manually. That is for manually. If you don't want to solve it manually, you don't need to show me all of that. Just go straight and get the inverse of that for me. And the moment you get the inverse of that, oh my God, getting the inverse of that is going to be super cool. It's going to be easy to find D. Okay, because the moment you get the inverse, that multiplied by S transpose Y, okay, then what if in the situation why I ask you this, you remember this guy, okay? That is looking like a leverage. Like if I want to find the leverage in data set, okay, the art matrix. That's an art matrix. If you take a look at that, it's an art matrix. Okay. So what if I ask you to find that from the data set? Okay. And what if I also ask you to show that M transpose is the same thing as M using the data set? When the transpose of a matrix is equal to that, there's a name we call that. Okay. And what if I ask you to show this? M squared is the same as M. Okay. This guy multiplied by itself. It is the same thing as itself. We call that idempotent. Theoretically, if I want to use this guy to multiply by itself, take a look at what I'm going to have. X transpose. Please pay attention. X, okay, inverse. Okay, X transpose. Then multiply by another one, X. Okay, X. Okay, transpose. Okay, inverse. Okay, S transpose. Okay, if you take a look at that, this guy, cancel that guy to be identity. What do I have? I'm having this guy back. Okay, what if I ask you to use data set for that? Okay, so get prepared for stuff like that. The probability that something like that will be on the exam is 1. It's 100%. It's 1. It's going to be on the exam. So if I were you, start practicing with your calculator. Start with all these ones. Okay. I want you to have the feeling that you want to have A in this exam. Okay. Can I ask you to now take a look at this? If I ask you to find this, I'm not asking you to find this theoretically. I know, please pay attention. Theoretically, this is going to give me identity, right? It's going to give me identity. I want you to use the data set so that the data set can, if the data set is if it is 2 by 2, okay, I'm expecting identity to be 1, 0. I'm expecting this 1, 0, 0, 1. 1, 0, 0, 1. Yeah, that's an identity. So use the data set to investigate that. Okay. Now, before I go, I need your attention on this particular question. Please pay attention. Now, you have this particular question. The data in this question represent a random sample of n equal to 19 city located in the contiguous United States. For each city, the following two variables are, we're considering latitude and high temperature. And this is plotted. This is scatter plot, right? High temperature against the latitude. This is showing, if you take a look at what I have, like a negative relationship. Okay, let's look at the summary statistics. The summary statistics we have for the mean, we have for the variances. Then we perform regression. Please pay attention. We perform regression. We have this output. Now, the question now, please pay attention. The question said, report the value of the estimate conditional mean of high temperature for a city whose latitude is 37 degrees, which means I want to find the expected value of high temperature given the latitude equal to 37. What are we, what, you know what they're telling you? Write a feeder model. What is a feeder model? You need to come here. Okay. You need to look at this. Do you see this guy? Okay. That's what I need. The model is Y cap. Don't forget, put a cap. If you just write Y, you're not going to have a full point. Y cap equal beta 1, or sorry, beta naught cap, the intercept plus beta 1 cap X. Okay, right now my beta naught is 182.664. My beta 1 cap is -3, negative that. When I plug that in, okay, you're gonna see anytime they mention conditional mean, the feeder module is a conditional mean because the feeder module is relating a response to the predator. Take a look at what I got. Now, after that, then when latitude is 37, then I'm just gonna plug that in. I'm gonna go that. Now, this is where I need you to pay attention. Report the value of the estimated conditional variance of high temperature for a city whose latitude is 37 degrees. They wanted to report this. Pay attention now. Please pay attention. Do you know that even if latitude is 38 or latitude is whatever, we have an assumption in statistics. What is the assumption? Constant variance, sigma squared. Okay, now I need the estimate of sigma squared, whether latitude is 37, whether latitude is 40, the variance of the response given any value of predator must be the same. That is homoscedasticity, constant variance. Now, we in the output, please pay attention. In the output, where am I going to see the estimate of the variance? Okay, and I want to show you right now. Estimate of the variance. Okay. Oh my God. It is right here. You see this guy? When they say residual, you know what that guy means? That guy means sigma cap. That's a residual standard error. The square of a residual standard error is a conditional variance of the model. Does that make sense? So, and that is the reason why I said this exam is going to test your knowledge of interpretation a lot. Knowledge of interpretation, knowledge of computation, and your theoretical knowledge. Now, and that was why I actually come here. That was why I come here and I square that. I square 4.9. That is coming from the regression output. Then that's what I have. Okay. So on Wednesday, I'm gonna go over this. Okay. And I'm also gonna go over situation where you got a lot of variables in the model, both combination of combination of categorical variable. This is where I'm going to start on Wednesday, where I talk about looking at the effects of knowledge, the IQ, years of experience, year of education, the tenure or monthly earnings, and that include the race and the location and so on like that. And giving, like I said, you are not going to use an R software. I'm not going to, I believe when I give you assignment, I give you data set, you use an arrow code. Okay, give me answer. But right here in the exam, I'm actually going to, give you the output in arrow. Then you are going to be the one. The only question that is going to come is we center on interpretation, computation, and your theoretical knowledge as well will be tested. This is where I'm going to stop today. Is there any question before I go? Any question? Go ahead. Yeah, you can come with any form of calculator, but I have a way to check if somebody puts information in the calculator. I have a way to check. So you can come with calculator you are comfortable with. Does that make sense? The calculator, let me tell you, the calculator that can perform matrix, that can perform matrix operation, like inverse, and so on. Like, God, I don't want you to waste your time in the exam. You have 15 minutes. Does that make sense? Have I answered your question? Okay. Any other question? Go ahead. Can you use R? Do you say which one is R? R Studio? Uh, because without Studio, it means you are going to come with laptop. Okay, let me do it this way. I will, like I said, use what you are comfortable with, right? Okay. You can come with your laptop if you want to use your hard, but I'm going to be checking around to make sure that you are not checking any other information apart from the software that you want to use. Is that a deal? Have I answered your question? Because you know what? I want you to use a tool that you are comfortable with. There are some that are comfortable with calculator. There are some that are comfortable with software. Okay, go ahead and use it. Have I answered your question? Any other question? Go ahead. Okay, as you emphasize the theoretical part again, the theoretical part centered on, you know, modules for dealing with multicollinearity. But there's not going to be principal components. I'm removing principal components regression and the partial least square. We did that last Friday. So, but the ridge regression, the lasso regression, the off subset selection, and the stepwise regression try to understand their theoretical basis on how they deal with outlier. Sorry, with multicollinearity. Then not only that, try to study um different kind of metric of evaluation like leave out, k-fold, what is the other one? Validation set. What is the difference between them in terms of weakness, in terms of strength, and so on like that. Does that make sense? No, the technique, a validation set where you split your data, right? That's number one. K-fold. Then leave one out. Reach, lasso, stepwise regression, and all subset selection. That makes sense? Okay. Any other question? I want you to come into the exam smiling because you know what to do, right? Okay. Make sure you all stay safe. Have a very, have a lovely day. Bye for now. Everyone, see you on Wednesday. Let me put it off.